This is lesson 10.3. The topics for this lesson are going to be LiDAR, light detection and ranging, DEM, digital elevation model, topography analysis, abandoned wells in Alberta, spill response, phase 2, intrusive investigation, SASplanet, plug-in terrain profile, create a new shapefile, layer, create a layer, new shapefile layer, extract.mde, raster, extraction, clipper, layer properties, single style, render type, Singleband, pseudocolor, mode, equal interval, classes 25, and the websites we're going to visit for this lesson are going to be Open Data Areas, Alberta, Maps, Map Viewers, and Shapefiles, Alberta Energy Regulator.
Hello everybody, this is lesson 10.3 and this lesson is an extension of lesson 10. The topic for this lesson is going to be how we can take some information about the topography of oil and gas fields, okay, and how useful are the digital elevation models that we get from LiDAR files, okay. Then today we are going to still working with the file we downloaded the other day. It was in this website, okay. The area of the work is going to be Fox Creek. This is the metadata for the file. As you can see here, the file is quite old, okay, but we are going to take some information anyway, okay. And also the accuracy, as you can see here, for the vertical one is 10 centimeters. That's really good. I'm not going to download the file because I did the other day. It is this file here. No, here Fox Creek, this one. This package, okay, this package is really good because we don't have to pass from the last files. Last files is the files we have the cloud of points, okay, the LiDAR files, okay, these ones, the last ones you see here, last, okay. This package is really good because they pass already from the last files to the digital elevation models, okay. We don't have to create the digital elevation models. In this package it's already created, okay. We have 4 different folders, as you can see here. This one is for the digital elevation models, but just the soil, okay. And this one, it says full feature. This is with the buildings, vegetation and everything. And also we have the high scale for every of these ones, okay, as you can see here. Okay, that's it. And also I would like to show you one file we have to download today. Is this website, but I'm going to show you how to find this one. Just go Google, here put abandoned wells in Alberta, share files. Share file, okay. And is this website, maps here, from the Alberta Energy Regulator. Then here you have to go to this option here, ST37 web page, okay. And here the file we are going to use today is going to be this one, Bodan Halls shapefile, okay. I downloaded already. Is this file here. And this is for the abandoned wells here in Alberta, okay. And also just to save some time, I downloaded this image from SASplanet, this software, okay? Is this area. That's the area we are going to be working today, okay? I'm going to put some videos here at the top to show the videos that we are going to show you how to use SASplanet, okay? Because we did a video already. And that's it, okay? This is the SASplanet. As you can see, the resolution for this image in this area is good, but here, as you can see, the resolution changed a little bit, and that's not really good, okay? That's the reason, because I took this area to have a nice image, okay? Then we are going to load all the information. We are going to be working in NAT 83 zone 11. This option here, apply. Okay, let's go to add the images. First of all, I'm going to load the image is this one. As we use SASplanet, we have the image already georeferencing. Okay, and this one is the real coordinates. And also we are going to load the digital elevation model, is this one. The one we are going to use is without vegetation, just the soil, okay? And it's going to be the first one, E35, okay? Open. Okay, that's it. We are going to be working with 3 different oil and gas fields. It's going to be this one, and this one, okay? But before to start, I would like to show you a few things about these fields and what kind of information we can find here with the high accuracy digital elevation models, okay? Because these files, these ones, okay, the digital elevation model has a really good resolution, okay? That's 10 centimeters, okay? For the vertical resolution, that's a really good one. We can do a lot of things with these kind of things, okay? But for example, if we have to do a spill response because there was a spill on this area, okay? You can analyze the topography of this area, okay? For example, if you use this plugin, terrain profile, you can create some cross sections. Okay, for example this one, but first we have to add the layer, okay? Select the file, okay, I'm going to take this one out, select this one, add, so you can see this one is this file, okay? Now let's go to see the topography in this area. For example, from here, sorry, what happened here now? Okay, I'm going to close, going to open again, going to select this one, add the layer, is this one, okay? One click, another double click to finish, okay? And that's the topography of this area. As you can see, this one here, you can see the elevation, and here you can see the distance. Everything is in meters, okay? As you can see, this small square is always in our profile. When we move, the square also move, okay? You are going to see the topography, okay? Then if you have a spill here, you know the spill is going to move in this direction, right? Let's go to do one section, cross section across the field. That's very nice, okay? You are going to see here the fill and cut, this kind of morphology, okay? And that's very interesting. I'm going to show you one thing here. I'm going to do this one bigger and this one longer, okay? I'm going to copy this one. I'm going to open Paint, I'm going to page here. Okay, this is our section. Okay, and this is the original topography, and also this one is the original topography. Then if we make a line from here to here, that is a reconstruction of the original topography. Okay, and then we can say that one is a fill, right? They remove the sediments from here and they place here to make a nice platform for the oil and gas fill. Okay, and that's very interesting, right? Because if you have to make a phase 2, right, you have to be aware that when contamination has to migrate, they are going to prefer to move through the disturbed sediments. Okay, then if you have a spill here, the contamination probably is going to move around this area here. Okay, and also one nice thing we can do in this one is where when we are doing the phase 2, I'm going to change the color for a blue one. Okay, we can have an estimation where we are going to find the natural sediments, the undisturbed sediments. For example, here we can say if you are going to make a borehole here, you are going to get the undisturbed sediments in this altitude. Okay, you can calculate the difference between this point and this point in meters, and you know when you are going to have disturbed material and undisturbed material. Okay, believe that it's pretty interesting if you want to get, for example, sometimes it's quite difficult to find the difference between fill materials and natural materials. Okay, because both of them are the same, right? That's just they excavated from here and they place here, right? And it's pretty similar, and sometimes it's hard. But if you have this information, you can predict when you are going to find the undisturbed sediments. Okay, for example, here is going to be 1047 more or less here. Okay, right there, and you can calculate what is the difference in meters, for example, from here. Okay, if you make a borehole here, there is 3 meters. Okay, in 3 meters you are going to get the undisturbed sediments. Okay, that's a pretty nice analysis. Okay, and also you can make any type of section. Okay, as you can see here, that's the fill oil and that's outside. Okay, that's the slope for this area. Okay, then in case of an spill, you can predict what is going to be the movement of the contaminant. For example, produce water. Okay, if you have the topography with a really good accuracy, you can predict the movement of the contaminant in this area. Okay, and also where the water is going to be accumulated, because there are some depressions or whatever, right? Now what I'm going to do is just be focused on the oil and gas field. Okay, to do that one, we are going to extract this area from the digital elevation model. Okay, I created already some, we don't need this one more, some folders inside this folder. Okay, I call digital elevation model and squares, and I'm going to keep the new files inside these folders. Okay, first of all, I'm going to create a new layer. It's going to be a polygon. The coordinate reference systems is going to be NAT 83 zone 11. Okay, and I'm going to save in this folder as a square here, and I'm going to put number 1, the name of the file. Okay, save. I'm going to press this pencil, and I'm going to press this option to add a feature. I'm going to add just the fill to identify features on the surface of the fill. Okay, press this one again to finish the addition, save, and now I'm going to extract the digital elevation model for this area. Just go Raster, Extraction, Clipper. Select the digital elevation model you have is this one. Now the old one is going to be saved in this one. Okay, in this folder, and I'm going to put the same number as the square, number 1, save. And I'm going to use this option. I'm going to use a mask. Okay, the mask is going to be this rectangle. Then I have to make sure the mask says number 1 is this one. Okay, and close. Okay, now I'm not going to use the big one, this one. Okay, I'm going to use just this one. Okay, and now we are going to do a color analysis for the topography. Okay, I believe it's very easy to recognize features on the surface with the colors. That's very nice. Go to properties, then single band pseudocolor, then equal intervals, apply. Okay, and now as you can see here, the maximum is 1052.8 for the altitude, and the minimum is 1047.3. Okay, the difference is almost 5 meters. Oh, it's even more than 5 meters, 5 meters and a half. Okay, but as you can see here, the colors we have inside the field is just this one and this one. Okay, then what I'm going to do, it's take, for example, 25 classes. In this way, the difference between one color and other color is not going to be 1.5 meters like this one. That's too much. In this way, we are not going to see any difference. Okay, but if we make 25 classes, okay, now the difference between one color and the next color is 20 centimeters. Okay, that's, I believe, a really good resolution to identify features on the surface. Okay, this one is the dominant color. I believe it's something like this one. Then I'm going to put a black color for this one. Apply. And next, for this one, I want to make a contrast. Then it's going to be a green one, for example. Apply. And for this one at the top is going to be a red. Red and black, they make a good contrast. Apply. Okay, now you can see here there are a big depression. Even we can change this color to make a contrast between green, and this one could be a kind of blue, for example. Okay, you can see the difference here is going to be a yellow. Apply. Okay, something like that, I believe is good. Okay, we have this field, and here we have a depression. You can see the blue color Even we can see here the legend between blue and green. The difference is 20 centimeters. Okay, we have a depression here of 20 centimeters. Okay, even around here, and the difference between the black here and the green, it's again 20 centimeters. Okay, then the difference between this black and this blue is 40 centimeters. That kind of depressions here on the field could be a lot of different things, right? Could be an underground storage tank. It was removed and that's they left the field like this one. Okay, could be a flood pit, could be a, I don't know, different things, right? Then if we go to the field, okay, we want to analyze this feature we identify on the map. Okay, maybe it's nothing, maybe it's something. Even we can use satellite images. Okay, we can buy high resolution, for example 2 meters by 2 meters. Okay, now every square here for this one is 1 meter by 1 meter. Okay, close. Then if you have money, you want to buy satellite images of high resolution, you can see what is the normalized difference vegetation index NDVA, and to see if the vegetation over here is healthy or it's not healthy, right? If the vegetation is not healthy, that is going to indicate the plants can grow up here in this area, maybe because of the contamination or something like that. Okay, you can compile more information. Also, we can see here with the profile, I'm going to add the layer. This is our profile. You can see here is the maximum of the depression. This is for the blue part. Okay, I'm not going to be aware of this kind of things here. That is because of the field and cut. Okay, that's the information for this field. We can move to another one. For example, this one. Let's go to do an analysis for this one. The steps are going to be the same. Okay, going to close this one, layer, new shapefile layer, polygon is going to be NAT 83 UTM Sun 11. Okay. Okay, we are going to save this one. Square is going to be number 2. And I'm going to edit this one. Oh, sorry. Is this option? One. I don't know what I'm doing. Number 1. Okay, finish edition, save, close. Raster to make an extraction, clipper. The file is this one, that's okay. The output file is going to be this one, number 2, inside the digital elevation model. Okay, save. And the mask, close. And the mask in this case is going to be number 2. Okay, it's the second one we're creating now. And okay, This is our digital elevation model for the field. Okay, let's go to see a little bit how the site looks like. Okay, let's go to add this layer here. Okay, you can see here the same as before, the field uncut. You can make a reconstruction of the original topography to see where you are going to get the undisturbed sediments in a phase 2. Okay, also you can see the general topography of this area, the natural one. Okay, okay, some different sections. Be careful with the vertical exaggeration, okay, because sometimes this one is too much. Okay, the exaggeration is too big. You have to be aware that we have here 300 meters, okay, from 0 to here 300 meters, but from here to here we have just 6 meters. The vertical exaggeration is too big. Okay, and now let's go to work with just with the fill. We are going to do the same as before. Double click here, go to Singleband pseudocolor, equal. In this case we have 58 and almost 64. Okay, it's going to be around 6 meters. Okay, I believe 25 different classes is going to be good. Apply. The dominant color here is the orange one. That's the one I want to put black color, or even the next one. Let me see. Yeah, more or less. Then I'm going to put this one. Cancel. Let me see. Maybe this one. Apply. Yes. Then this one is going to be a red one because it makes good contrast. Apply. And this one is going to be, for example, a blue one. Apply. For this one, I'm going to put a kind of green, for example. And here for this one, green yellow maybe. No, this yellow. Let's see. Okay, apply. This one, a white, for example. And this one, a purple. Apply. Okay. Okay, that's the colors we have. As you can see, red, the difference between black and red, there it is just 20 centimeters. For green to black is 30 centimeters. Okay, the big depression is here in this area. Also, we can add the abandoned walls to see where is the wall. Okay, is this one open? We are going to put that one at the top. Here we have the wall. We can change the symbology for the wall to see better. Something, anything could be good. Apply. It's very, very small. Number 5. Apply. And I'm going to put a yellow one. Apply. Okay. We have the wall over there. Okay. We have the entrance of the list over here. Okay, and we have some depressions detected here, 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 and here. Okay. Then, as I said before, you can download satellite images. Even could be images from Sentinel-2. As you know, they are totally free, and we was using these kind of images in 3 videos I did already. I'm going to add the videos over here if you want to see that videos. Then we can compile some information with LiDAR technology, also satellite images, okay, and see if the vegetation over here is healthy or it's not healthy. You know, if the vegetation is not healthy, that could mean maybe something, right? If the, for example, the NDVA it's not really good, the values are not really high, maybe it's happened something there, okay, that we have to analyze. Okay, let's go to see on the profile how it looks like that things there. For example, from here to here. Well, first I have to add the okay. Looks very flat, right? We have the depressions there. Here the depression is bigger. Here is too much. Okay. And now for the last one, we are going to analyze also this one here. Or maybe this one, that because we have the abandoned well there. Let's go to analyze this one to see what's going on here. Okay, I'm going to take this one out. It's going to be this area here as before. Layer, create a new layer, save file, polygon, NAT 83. Okay, okay. We are going to save this one in a square. That one is going to be number 3. Save. And let's go to edit this one. Let's go to do something like this one. Okay. Save. And now let's go to extract the raster, clipper, salad is going to be number 3. Save. We are going to use the mask number 3. Okay, okay, close. We can analyze first a little bit the topography in this area as we did in the other ones. I would like to add this layer. Okay, this is the filter to see just a little bit the topography. What is the direction, the natural topography of the area? Okay, and we have the filter. Okay, now let's go to analyze the fill. Let's go to change the colors. First, let's go to change the colors. Let's go to select number 3. Double click. Equal, as you can see here, the difference is almost 6 meters. Okay, 30 classes could be good. Apply. We have a different colors here, but the purple one, like this one, could be the black one. No, maybe this one. Okay, apply. No, this one. Apply. Oh, this one maybe. You have to play with these values. Okay. Then that one is going to be red. This one is going to be blue, for example. This one is going to be green. This one is going to be yellow. This one is going to be yellow also. Apply. And this one is going to be a kind of this one, this kind of green, soft green. Okay. The difference you can see is 20 centimeters. That's good. On this field, it's quite complicated, but looks like there is a depression here. Also in this area in general. It's good to see the profile here at the layer number 3. From here to here. Yeah, there is a kind of depression here, but in general the field it's not so flat. You can see here the slope. Okay, this direction is more flat. Okay, that's the things we can identify in this file. There is something here blue higher, like a pile. It's a pile there. Okay, that's the end of this video, and that's the final thing we are going to do with the LiDAR technology. Maybe at the future we are going to do more videos with the LiDAR. Okay, thank you very much for watching, and see you on next time.